Good morning, good afternoon, and good evening, and welcome to Umlink Energy Speaks Back, powered by Arc. My name's Paul Webb. I'm the founder of B2B Energy, and I'm your host. And weekly, I present to you energy experts from around the world. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. Before we get into our interview today, I would like to recognize our sponsors. And they are Umlink, who are taking the confusion out of energy management, Clean Energy Revolution for their knowledge and their networking in the renewable world, B2B Energy for their 11-week energy program, managing organizations' third largest expense, Hark Systems, renowned for their energy software, Alexis Energy for their power management, led by Vision, who are an LED and a controls organization, Watts for their electronics and EV transition, Carbon Black Global for their waste to energy initiatives. And lastly, our certificate partners, Aster Energy. Welcome to episode 68 of Umlink Energy Speaks Back, powered by Hark. My special guest today is an HVAC expert whose goal is to evolve the HVAC industry from business as usual to becoming a sustainable, energy efficient, climate friendly, and at the same time making it affordable for the future of our planet. So without any further ado, I give you Tiger Aster. Good afternoon, Tiger. How are you today?
I'm doing well, Paul. Thanks a lot.
Good afternoon for you, and it's very early in the morning for myself. So I've got a coffee on hand, so we should be okay this morning.
Perfect.
Tiger, I've met you through LinkedIn, through some associates on LinkedIn, and we've had a couple of Zoom calls and things. So for the benefit of our audience today, can you give us some background to yourself and what you're doing in India?
Yeah, sure. Thanks for connecting with me on LinkedIn and setting this up. Really appreciate that. So my name is Tiger Aster, and I run a company called Torowatt. Torowatt is a company that works on sustainable air conditioning solutions and providing affordable thermal comfort to the masses of people. Unlike traditional air conditioning technologies, my company has developed a technology which uses fresh outdoor air as the main source of air conditioning. So we've reduced that dependence that we have on air conditioners for replacing the same air again and again. Now, rather, I would say recirculating that same air again and again. What I am currently doing in India is bringing out two products that are in the commercial side of air conditioning. One which uses no compressor at all and provides the equivalent of 5 tons of air conditioning, while using just about 1 kilowatt of power. So we're looking at applications where it can be actually run on solar, and that helps in the energy transition and being sustainable, moving towards renewable energy and the whole energy transition. The second solution that we are bringing to market is again an air conditioner, which is a 5-ton equivalent, but this is targeted specifically for the coastal cities, which of course are highly dense areas. But at the same time, we were able to reduce the compressor capacity. So a 5-ton air conditioner using just 3 tons of compressor power. That is a significant reduction in energy use, both on the captive side as well as the operating side. Now, what's really interesting, I would share, is that because there has been a large disconnect with the built environment and the ambient, we see a great opportunity to bring in these fresh air solutions, especially in a time like right now, where we have so much of uncertainty because of COVID, because of the Delta variant, with Omicron coming in as well. So these kind of solutions help in mitigating these pandemic-like situations because of the fresh air.
The interesting point for me is that, so through my day-to-day and energy management, a lot of the work that's done around the air conditioning systems, we don't seem to be changing that technology as such. And we just focus on the control side, don't we? Turning it off at different times, changing the set points. And it's interesting that you've gone into the hardware of it, which intrigues me, really, is that you've actually changed the whole technology about the air conditioning system and focused on the actual how it works. And I'm intrigued as well. You're right in what you're saying is we're bringing in outside air temperatures, which when it's slightly cooler outside, we should be doing that anyway, shouldn't we?
Well, we should be doing it, but we should be doing it with a different kind of a technology. I mean, it's not possible to bring in outdoor air without, the IAQ versus energy war.
Yeah.
And that's basically the reason why ASHRAE 62.1 for every revision has changed the amount of fresh air to lower and lower levels. Yeah. Now, it definitely has been a challenge, but how we're seeing it now is by bringing this building ambient connectivity and providing sufficient technology in there on the hardware side to be able to recover as much energy as possible. That, takes us into a different kind of a domain of providing that indoor air quality, that oxygen-rich environment that is really essential for work, play, lifestyle, health, and all the other benefits that come with it.
And when we spoke on Zoom, you mentioned that you've been traveling with this technology. What countries have you been exposing this technology to currently?
So we've been exposing this technology in India, in the Middle East, in Canada, in southern US, Mexico, and a bit in Brazil. So these are some of the countries that or areas that we've been looking into to taking our technology.
And have you got any particular systems in place already?
Yeah, so what we did was for about 10 years, we ran a company doing research and development. And while doing that, we had a lot of systems designed and built for customers. So we've got customers ranging from GE, McDonald's, Boeing, Tata Motors, GEM schools in the UAE. So various different applications, which actually helped us to evolve and bring this technology to the level that we're able to now take it to the mass market.
Right. And presumably you've got, there's obviously case studies there already and evidence that you've delivered these savings. And is there like a before and after review on it? So can you see what it was doing before and what it's doing now?
So unfortunately, we may not have the complete detailed information available right now, but there's definitely a couple of case studies which can be shared. Right. For some of the applications. May not be for all of them, but quite a few of them.
Brilliant. And Tiger, tell us about your background personally. What made you get into this?
Great question. So I've been an IT guy for a very long time, and somewhere around 2007, this thought struck me that, hey, you know what? IT is not going to fix the world's problems. And some of the things are real hardware issues that need to be sorted out. And that's how I got into this extremely interesting field of HVAC, which is by far the most non-sexy field in the energy transition.
You think?
Yeah, absolutely.
You think it's a non-sexy or a sexy?
It's an absolutely non-sexy side of it because EVs are gorgeous.
Yeah.
And renewable energy and anything solar and hydrogen is like, wow, man. But when it comes to air conditioning, you're like, really? Air conditioning?
Yeah, I think
that's a challenging part.
Yeah. when you look at a building, especially commercial buildings, it must be about in the region of 30% of their controls in their building or their energy management portfolio is going to be surrounded around air conditioning. So,
correct.
And I'll be honest, as an energy consultant, I've always struggled finding a solution for air conditioning. And when you look at them profiles, the reason why the profiles are so high is because chillers and air conditioning systems. So
true. So one of my friends told me some time back, nobody gets fired for buying a carrier. So that's an interesting analogy to take with it. But I think that is changing though, because if you see the way that the technology has evolved, air conditioning basically is a 120-year-old technology with many legacy companies in that field. Now, over the 120 years, it's the last 30 years that we have seen a higher number of energy efficiency improvements. However, if you look at the scale of improvements, they've always been incremental. So you're looking at something like 0.5% to 1.5% per year as the improvement. And that, when you look at it on a grand scale, is a very minuscule, kind of a improvement when you compare it to an internal combustion engine, which is now obsolete and becoming all electric. So that changes the game completely. So that's why there's a lot of scope in HVAC to become a lot more energy efficient.
And what I find as well is people don't get it right. I travel to Asia a lot, and when I'm in Asia, it's just far too cold. And when I'm coming from the outside into that very, very cold, I always say this, as a Westerner, it makes me feel ill. I have a couple of days where I'm not used to it. I'll be, quite off for a couple of days. And I've put that down to the air conditioning systems because I'm not used to it.
Yeah, absolutely. I agree with you. So what ends up happening is we end up getting a thermal shock every time we transition from one space to another, whether it's from the outside to the inside or from the inside to the outside. This is something I think we need to educate our users about. It's basically what we are trying to do is build thermal comfort and not a thermal shock. Yeah. So transitioning from our body temperature to something which is relatively more comfortable rather than being cold. I would like to bring a new concept to the market where we stop reading temperature as numbers and actually start going by how people feel. So do you feel hot? Do you feel warm? Do you feel comfortable? Do you feel cold? Are you freezing? If we go by that kind of a form, we can actually train our solutions when we look at the AI and the ML part to actually understand what makes us feel the most comfortable.
Maybe we need like a thermographic sensor, which matches our body temperature to the room temperature or something like that.
Possibly,
Gets it close. Yeah.
Yeah, that way, you don't get too cold and you don't sweat.
Yeah.
But at the same time, you're comfortable. So, we also need to change some of our habits of wearing suits everywhere, which is not really necessary. I mean, we could be in a shirt or a t-shirt and be comfortable.
Dressing appropriately.
Absolutely.
Yeah. How many times have you gone into an air conditioning building and everyone's walking around with fleeces on and jumpers?
Every single time.
Yeah. And I bet you see that all the time where you are in India.
I do.
Yeah.
I do.
It's crazy. It's crazy. So what with your technologies and what you're doing here, do you still get the same temperature ranges? So even if you had to go right down to these temperatures, and what I'm thinking about is things like data centers where they have to be run at, say, 16 degrees and then them lower temperatures. Can you still maintain these levels?
Well, actually, I'm so glad you brought that up. It's a myth that you have to run the data centers at 16 degrees C. The latest ASHRAE standards allow you to go in around, I think if I'm not mistaken, 27 and exit at 35.
Right.
So that changes the whole game. You don't have to depend on air conditioning to do it. I mean, Facebook doesn't use air conditioners to cool their data centers.
Right.
They use evaporative cooling. If you look at Amazon is now looking at changing their strategies because their energy use is going really skyrocket with the amount of air conditioners that they have to use for something that is pure sensible heat.
Yeah.
I mean, there is no humidity in a data center.
That that temperature where what I've just quoted obviously is the IT temperature that's been stated, isn't it? That's what they want the temperatures to be run at.
True.
Because I would be happy with 16 degrees, but they're always trying to set them down lower. So I'm trying to sort of maintain a level. So we can, technology's got better and better. I'm talking to you today on a little laptop. Well, this time 10 years ago, this laptop wouldn't have been as small. I wouldn't have been able to have all that going on. And dare I say, I'm quite old, really. I remember when the first computers, we used to be even, massive desktop computers and computers the size of a room in a data center. So we should see efficiencies there within computer systems, which should need or would need less cooling anyway.
Absolutely. So you look at our laptops today, our chips are running at 70, 80 degrees centigrade. And even with 35, 40 degrees air going through, we don't see that much of a drop in performance. When it comes to data centers, yes, of course, there are a lot of factors about reliability, about consistency, and being able to continue with the throughput throughout. And in those applications, yes, I do agree that you need to set your temperature set points. But I think going to extreme lower temperatures are actually harmful because you end up with condensing atmosphere inside. That means you could actually form droplets in case of a failure of your aircon. And that is a major challenge.
Presumably, if we're going to reduce this energy down so much, initially we could have the air conditioning running more, can't we? Not having to shut it off. So we could, I've been involved with organizations where they've taken advantage of the night cooling and they've kept the systems on all night to cool the fabric down. And, the best areas to start cooling down isn't necessarily the space temperature, it's the fabric itself to start not holding that heat. So do you think that is what we're seeing more often regarding the timescales of these systems being extended?
So as we get closer to getting towards net zero, I think you'll see a lot of these strategies being adopted, where you're talking about night-free cooling or night flushes. And this is going to happen in commercial buildings as well, in the buildings where it's not already happening. Also, there are other modes that can provide cooling without refrigeration. So those will also come into play in the near future, and especially to get towards those net zero goals that pretty much every country is aiming for at this point of time.
Yeah. And what's going to be the ideal application for this product? What sort of buildings are we going to likely to be able to, what's going to be your niche initially?
So initially, we're launching these two products for India and then a simultaneous launch in the US. These are predominantly 100% outdoor air systems. So one, we're looking at the buildings that are not too tight, because you notice in Asia, most of the buildings are not tight buildings, unlike London or the UK or in the US, in colder regions. So providing thermal comfort for these kind of buildings is one of the application areas. The second application area that we are very keen on is providing this ventilative air conditioning for schools. And this is really important, especially in this current scenario that we have right now, where because of a lack of ventilation, we end up having both a reduction in cognitive function and learning abilities. At the same time, there is this fear of a constant spread, even though we still use ventilation. But CO2 as a proxy for what's in our air gives us this option of bringing in an additional amount of fresh air into these spaces where the amount of people are much higher than, say, a home or an office building. The density is a lot higher.
Yeah. Because obviously, the more people in a building, the more air changes we require.
Correct.
Okay, and especially in schools, because that's where, you know, that's where the viruses are gonna. That's what happens, isn't it? Your children go to school, they come back and bring the colds back into the household.
Correct.
You know, that's in the normal times when we used to have with just a normal cold. But now it must be, you know, we must be seeing it everywhere where we're bringing that virus back home as such, and the spread of it. There's obviously an area where we need to focus on. What about hospitality?
Hospitality is a great industry, and bringing in fresh air is key to a lot of the hospitality infrastructure. Primary reason being that many of the star level hotels have very expensive drapes and furniture, and you don't want any kind of mold fungus growing in there, especially if you're in a tropical region. And inadequate fresh air kind of leads to these problems. And the housekeeping head would probably have to lose his job, because if the presidential suite starts smelling, it's a huge problem for the reputation of the chain itself.
What sort of have you looked at the return on investment on these systems?
Right. So this is actually a very nice question when you look at energy versus money versus well-being versus also the kind of indoor pollutants that are inside the space. So I would say that our equipment typically ranges in that 2 to 3 year sweet spot when it comes to payback. And in comparison to many other kinds of interventions, this is a fairly decent return of investment.
Yeah. I do find that organizations will look at 2 to 3 years. Initially, you know, when we go into looking at organizations, they like the low-hanging fruit, first of all. We just get on with that. And then we focus on the medium cost, and then we go into the capital cost. So it's a capital cost investment that you're looking at, which is something I would expect. And then that leads me into, is it going to be ideal for retrofit or for new build?
So our solutions fit into both contexts. So I wouldn't call it a retrofit, but I would call it a retro replacement.
Yeah.
Because these are basically deeper retrofits. You're changing something which is of a very old technology and updating and bringing in something brand new. So that way it would be a retro replacement or just a traditional retrofit.
And excuse all my questions now, because it's opening up loads of different doors in my head now. So
no problem.
How long would it? What's the like the logistics of getting this new system in, replacing it from the old? Is there much of a change? Is there much upheaval? Has the organisation got to go through a lot of change from going from one system to the other?
No, transitioning is quite similar to what would happen if you were replacing a traditional unit. So we're not changing the form factors too much, apart from making it, I would say, about 30% larger in voluminous size. So it should be convenient to transition from an older solution to a new one.
And the system has to be mounting outside.
So there are different.
Some of the system.
So some could be mounted outside, some could be inside, some could be out the wall, some could be in a mechanical room. So it depends on the configuration.
Yeah.
We'd be able to work with it.
So I'm really interested in this space. We spoke the other week, and my mind's been buzzing about this because I've got loads of areas where I think I haven't invested enough time in that, only in sort of looking at their set points, looking at how they're controlling it. So tell us what your short-term goals are going to be for 2022 now.
So short-term goals for 2022 is basically to launch these two solutions into the market, get sufficient market traction and user buy-in, get that shift from temperature to move to adaptive comfort.
Yeah.
And I think getting there and a few megatons of CO2 avoided, I think that will keep us happy.
I'm sure it will. Is it, just quickly, is there any gases involved with your system like there was with air conditioning systems? Do we still have to put the same gases or similar gases into the system?
So one of our solutions is a compressor-less system, so there are no gases at all. We use water as a refrigerant there. In the second system, which we call Space Cool, we use a refrigeration system in there, which is half the capacity. And there we do use a refrigerant. We use a natural refrigerant in place of the ones that are currently available as the HFCs and HFOs. We use propane or R290. And we use a very low charge, so it's within the permissible limits of many of the regulations that basically limit the amount of charge per circuit.
So I'm presuming that it's going to be a win-win situation for reduced energy, reduced installation as such, and possibly reduced maintenance going forward?
Absolutely. So maintenance-wise, we looked at it from a very different point of view. And some of the people who are with us on our team come from the maintenance background. And so what they helped us build was a solution which was a plug and play when it comes to refrigeration side, that no work should be performed on site. It would be to remove a component and plug in a new one and see that the customer has a zero downtime when it comes to his product and the thermal comfort that he requires. So yeah, maintenance wise, it's definitely a reduction of time and effort at site. And that ensures that, you get that near zero downtime.
And Tiger, you're in India at the moment. Where was you before you was in India? Because I've got a feeling you was in somewhere in Asia, wasn't you?
So a while back when that light bulb, just came on, I was in Thailand.
Right.
And India being a hot country and the place where I was born, it was like, okay, it's time to give back to the country and see what we can do to help the people out here who actually live in a very, very hot and hostile temperature zone, especially as the summers keep getting hotter and hotter every single year these past couple of years.
Exactly. It's an amazing story. So, Tiger, it's in this time at the moment where I like to put my my guests on the spot, and I've asked you quite a lot of questions about the technology, but now I'd like to ask you: is there something you can give back to our industry today as a takeaway for our listeners?
Oh, absolutely. I would love the industry to know that please do not compromise on fresh outdoor air. Even though it looks like it might be a little more expensive, the health benefits of it outweigh the costs. And there are technologies coming to market which will help you, achieve that indoor environment quality and energy goals. So please stick to more fresh air, keep your people safe, keep the children safe, and live a happy life, live a good life.
And at the same time, gain loads of benefits from your technologies and what you're saying. Where can our listeners go and find out more about what you're doing, Tiger?
Sure.
Website?
Yes, we do. You can always visit our website. It's www.toro, Toro, watt.com.
Brilliant. Well, I'm definitely going to go and get on that website this afternoon. I'm going to make sure that Umlink as an organization, this is our network of and our forums, we make sure it's promoted on there. So that's it's in the right place for you. Tiger, it's really great catching up with you. Apologise for our timings yesterday, but it's great that we've caught up, and it's been a really great pleasure to interview you today.
Absolutely. Delighted to talk to you, Paul. Thank you so much for the opportunity.
Thank you. And Tiger, you and your family, be safe, especially in these times.
Equally to all your viewers and listeners as well. Thank you so much.